Alright, in this video in our series of differential equations, we're going to look at equations called Euler homogeneous or homogeneous, and these are equations that take the form of dy by dx is equal to some function of y over x, okay, and these can be already separable, and if they are, you could solve them using those techniques, or they could be linear, but they also can be non-linear. So that's why this is helpful. You know, if we've got something that we can't solve with the techniques we already know of solving separable differential equations, then we can use this substitution. Y is equal to xv, and that gives dy by dx is equal to x dv by dx. That substitution, and then getting dv x dv by dx plus v equal to f of y over x, but that will, well, the whole idea of the substitution is that f of y over x becomes a function of v, because if you sub in y x over v, the x's cancel and you get a function of v. Okay, and then you subtract this v over on both sides, so you get x dv by dx equal to f of v minus v. God, the handwriting is atrocious today, sorry about that. And then we integrate 1 over f of v minus v with respect to v, and then we integrate 1 over x with respect to x, okay? So that's the trick. We're now going to look at a specific example and see how this works. Right, so we've got a function here, dy by dx is equal to y over x minus 1/4 y cubed over x cubed. Okay, now this is a function of y over x. We've got y over x minus 1/4 y over x cubed. Okay, so we're going to use our substitution, y equals x v, and putting this in gives us, as shown before, x dv by dx plus v, and here we'll have, well, the y over x just becomes v, and then we get minus 1/4 v cubed. Okay, now these v's actually cancel, so now we've got x dv by dx equal to a function of v, as we thought we would. So now we're going to minus 4 over v to the minus 3, and then integrate with respect to v, equal to the integral of 1 over x with respect to x. These are pretty standard integrals. Here we get 2 v to the minus 2, and then here we get ln the modulus of x, and then we're going to plus or add a constant on the end of this side. Now we want to substitute v is equal to y over x, because we're trying to find y in terms of x, and what that's going to give us 2x squared over y squared is equal to ln x plus c, and now rearranging, so multiplying up by this, dividing by this, and then taking the square root is going to give us y is equal to 2x squared over ln of x plus c to the power of a half. Okay, and that concludes this example. So, with differential equations, what we're essentially looking to do is get a load of tools, so we know how to solve separable equations. In the last video we showed how to use an integrating factor. Here I'm showing you a substitution you can use in certain forms, and we'll go through all these different tools. But then the real test with differential equations becomes looking at it and seeing what we want to do to solve it, what we want to try to solve this problem. And the only way you're going to get that is really by practicing questions. But first of all, you want to be familiar with as many of the tools as you can, so that you're giving yourself half a chance to find the easiest way to solve these equations. And you will find some of them can't be solved analytically like this, but obviously all the ones on your exam will be. And it depends what level you're at, but yeah, if you're watching this video, you're interested in solving these analytically. So it's good to learn all these techniques and to go through a lot of practice examples. For now, I hope you enjoyed. If you did, please like and subscribe, and I hope to see you in the next one.